Here is a continuation of the review sheet for the final exam 2019, probably years after that as well. So number 21, solve 6x squared equals 54. This is an x squared equal to a number. There's no b term, so I can solve using algebra. I'm going to divide by 6. So x squared equals 9. Square root both sides. Don't forget your plus or minus. So x equals plus or minus 3. Remember that an x squared should always have 2 answers. An x cubed should have about 3. So unless you have double roots, so pay attention to that. Number 22 is in your vertex form or completed square form, so we're going to also solve by algebra. Add 17. So 4 times x plus 3 squared equals 80. Divide by 4. X plus 3 squared equals 20. I'm going to take the square root of both sides, plus or minus the square root. So x plus 3 equals plus or minus 20 is 4 times 5, so that can simplify to 2 radical 5. Sorry, that's x plus 3. And then subtract my 3. Remember, I can't subtract the 3 from that 2. That's 2 square root 5, can't be separated. I can't subtract the number in front. If I left it as square root 20, I wouldn't be subtracting the 3 from the 20, so I can't subtract anything from that. So x equals negative 3 plus or minus 2 radical 5. Number 23, write the expression as a complex number in standard form. Standard form is a plus bi, so that's the real number first and the imaginary part second. So we're going to add our real numbers together. That's our 9 and our negative 6, and then we'll add our imaginaries together. So negative 9 minus negative 6. Minus negative becomes plus. I'm going to distribute the negative to the 9. That's usually where people make mistakes on these types of problems. So negative 9 plus 6 is negative 3. And negative 2 minus 9i, because it's minus positive 9i, becomes negative 11i. And that is in standard form. Number 24 is dividing. To divide complex numbers, we multiply by the complex conjugate of the denominator. So we're going to multiply by, not x, we're going to multiply by 8 plus 9i, 8 plus 9i, and we're going to use distribution FOIL, so 1 times 8 is 8, 1 times 9i plus 9i, negative 8i times 8, negative 64i, and negative 8i times 9i is negative 72i squared. That's my numerator. My denominator becomes 8 times 8, which is 64. 8 times 9i plus 72i. Negative 9i times 8, negative 72i. Negative 9i times 9i gives me negative 81i squared. Now my I terms cancel out in the denominator. That's the whole reason we multiply by the complex conjugate, so it will cancel out. And that becomes negative 81 times negative 1. I squared equals negative 1. That's a big one to remember, because we never leave our answer with an I squared in it. So that becomes 64 plus 81, which is 140 plus 5, 145. So our denominator is 145. And 64 minus 9. This becomes negative 72 times negative 1, which becomes plus 72. So 8 plus 72 is 80. And 9i minus 64i is negative 55i. And then we can divide everything by 5. We can simplify. So another way to think of it is we're going to factor 5 out of the top. So we have 5 times 16 minus 11i over 140. 145 is 5 times 29, and I can divide out the 5s. So 16 minus 11i divided by 29 is the final answer. And the other way to look at that is to just divide all 3 terms by 5. And you can only do that if all of them are divisible by the same number. So number 25, solve x squared minus 10x plus 41 equals 0. I can use any method on this. It's not factorable because 41 is prime and 41 plus 1 is not going to give me 10. So I'm going to choose to complete the square because I have a coefficient of 1 and my middle term is even. So x squared minus 10x equals negative 41. I'm going to put that minus the 41 to the other side. And then I take my b term, negative 10, divide it by 2, and square it. So we get negative 5 squared, which is 25. I have to remember to add it to both sides. Remember, that's the cardinal rule of algebra. Whatever I'm doing to one side of the equation, I have to do to the other to keep it balanced. And then I can factor x squared minus 10x plus 25, that's x minus 5 squared, equals, let's see, that's negative 16. And take the square root. So x minus 5 equals plus or minus the square root of negative 16 is 4i, and then add 5. And it's x equals 5 plus or minus 4i. That's my final answer. You might see it in a multiple choice, 5 plus 4i and 5 minus 4i. You could see it written either way. Number 26 says completing the square, so I'll do it that way. But remember, on this test, it's multiple choice. We're not checking your work, so you could solve it any way you want. This one's going to work out just fine, though, because if I divide by 2, that's the first thing I have to do. If there's a coefficient, divide by 2. So we get x squared, that's up here, plus 10x equals 7. And this is similar to the one we just did. 10 divided by 2 squared. 5 squared is 25. So I'm going to add that to both sides. And we get x plus 5 squared equals 32. Sorry. Equals 32. And then I can take the square root, plus or minus the square root. X plus 5 equals plus or minus, that's 16 times 2, so 4 square root 2, minus the 5, and x equals negative 5 plus or minus 4 square root 2. Again, you could write it as negative 5 plus 4 square root 2 and negative 5 minus 4 square root 2. So here is the answer to 25, and here's the answer to 26. All right, find the maximum value of the quadratic equation. Maximum or minimum. Mean, find the vertex. Specifically the y value of the vertex. So to do that, our formula is x equals negative b over 2 times a, and then we have to plug that in and find the y value. So we have b, which is 4, so negative 4, divided by 2 times a, which is negative 1. And this is negative 4 divided by negative 2, which is positive 2. So x is positive 2. And we'll plug that in. Y equals negative 2 squared plus 4 times 2 plus 77. And that's negative 4. We're going to square it and then apply the negative. So negative 4 plus 8 plus 77, which is 4 plus 77, 81. So the maximum is 81. It's not the vertex as an ordered pair, but the maximum is just the y value. Number 28, use quadratic formula to solve. X squared plus 7x plus or minus 1, so this was 27 over here. Quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So my a is 1, my b is 7, and my c is negative 1. So negative 7 plus or minus the square root of 7 squared minus 4 times 1 times negative 1 all over 2 times 1. So negative 7 plus or minus the square root of 49. Negative negative makes this positive, so plus 4 over 2. Which is then negative 7 plus or minus the square root of 53 over 2. 53 can't be simplified, so that's my final answer. And you might see it again as two separate fractions. Number 29, 9x squared minus 24x plus 16 equals 0. I'm going to move that to the other side. My first attempt at solving a quadratic, if it doesn't give me the direction and how to solve it, is going to be using factoring. So first I see a perfect square, and a perfect square. So I'm going to see if this is going to work if I try 3x and 4. 3x and 4. That's outside gives me 12x. My inside gives me 12x. If I need it to be negative, they both are negative, which then gives me the positive 16. And that's a whole lot faster than using quadratic formula. And completing the square would be a nightmare on this, because if you divide by 9, you get a fraction in the middle. So then I can solve 3x minus 4 equals 0, plus 4. 3x equals 4, so x is 4/3. Now it's a squared, so why didn't I get two answers? And that's because this is a double root. So when I have, technically, the answer 4/3 twice, but we only write it once, and that's where the second answer comes from. So, number 30, a rock is thrown from the top of a building. The distance in feet between the rock and the ground, t seconds after it is thrown, is given by d equals negative 16t squared minus 2t plus 733. How long after the rock is thrown is it 400 feet from the ground? So that's the distance, the 400. So that's going to go in the equation for d, negative 16t squared minus 2t plus 733. And this is going to look like a quadratic formula problem. So I'm going to subtract 400. So 0 equals negative 16t squared minus 2t plus 333. Now I try to factor something out of that, but 333 is odd, so that's not going to help me. So I'm going to use quadratic formula. Negative b, so negative 2, plus or minus the square root of negative 2 squared minus 4 times a, negative 16, times c, 333, all divided by 2 times negative 16. So that's 2 plus or minus the square root of 4, and 4 times 16 times 333 is 21,312. So plus 21,312 over negative 32. And I get 2 plus or minus the square root of 21,316 over negative 32. And then I'm going to try to square root that, and I don't think it's a perfect square, but it is. Lovely calculators, plus or minus 146 over negative 32. So when I do 2 plus 146, I get 148 over negative 32. And then when I do 2 minus 146, I get negative 144 over negative 32. Now the negative answer is going to be extraneous because it's time, so I can't do that. That's not the correct answer. And this is equal to 4.5 seconds. And lastly on this page is synthetic substitution. Use synthetic substitution to evaluate. I'm going to rewrite the problem here and then I'll make more space. I set it up like this, right? In the box, when I'm just evaluating, k is 4, so 4 goes in the box. And I write down my coefficients, making sure I fill in zeros for any missing terms. So 2k squared, take k cubed, negative 2 for the k squared, 9 for the k, and -3. It's not missing anything. And then I draw the line with a space underneath it so I can fill in my numbers. I bring down the 2, I multiply the 2 times the 4, and I put it in the next column. I put 8, and then I add to get 6, and then we multiply the 6 times the 4 to get 24, and we add it to get 33, and then we multiply 33 times 4. That gives me 132, and then we add again to get 129. So we're adding each number, and 132 minus 3, 129. And so the answer is what's left over in the remainder box. I'm not dividing, so the what I get from my evaluation is the number in that box, 129. Okay, find the product of n plus 4 times n squared plus 3n plus 5. There's lots of ways to do this. Some people like to do the array, n plus 4. And then here we'd write n squared plus 3n plus 5. And then we'd multiply. I like to use our algorithm where we place them on top of each other. And they multiply everything by 4. So 4 times 5 is 20, positive 20. 4 times 3n. 4 times 3n is 12n, positive again. 4 times n squared is 4n squared. Then I leave a space, just like you would before, and we multiply the n times 5. So 5n, making sure to line up my like terms. Then I get n times 3n. That gives me 3n squared, positive again. And n times n squared, n cubed. So then I add up my like terms. N cubed plus 7n squared plus 17n plus 20. And then the other way to do it was just to distribute the n to everything and then distribute the 4 to everything, which is exactly what happens in any of these methods for solving this. Number 33 says divide. I can use synthetic substitution on this one because there's no coefficient. So we're going to use 3 as our number. And then our coefficients are 2, -4. Now this is missing the x squared term, so I'm going to put a 0, -12, and -15. And then just like we did on the last problem that said synthetic substitution, we bring down the 2, we multiply 2 times the 3, and put it in the next column, so we get 6. And then we add, going down, so we have 2. We multiply again, 2 times the 3 gives us 6, and we add to get 6. And then we multiply the 6 times the 3, we get 18. And we add -12 plus 6 to get, or -12 plus 18 to get 6. And we multiply 6 times 3 gives you 18, and you add to get 3. Now this is your remainder when you're dividing. This is our constant. And then this is our x. This is our x squared, and you just go in order, starting at the back. And this is x cubed. Our answer should always be 1 less because I'm doing one very exponent less because I'm doing x to the 4th divided by x, which should give us an x cubed. So the final answer here is 2x cubed plus 2x squared plus 6x plus 6 plus 3 over what I divided by, x minus 3. And that's my final answer for number 33. And then when it says list the possible zeros for number 34, that's our p's and q's. Our p's are all the factors of the constant. So that's 1, 2, 3, 4, 6, and 12. Those are all the ways to get 12. Our q's are all the factors of the leading coefficient, which in this case is just 1. And then all the possible rational zeros are plus or minus p divided by q, and all the combinations. So it's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. If there was a coefficient on the x to the 5th, and we had, say, a 2 with our q, then we would write another list with all of these numbers with a denominator of 2. But that's not our problem here. Number 35, simplify 8 to the 4/3 power. And we know how to write that as a radical. It's the cube root of 8 to the 4th power. The denominator is the radical, and the numerator is the exponent. And the cube root of 8 is 2, and 2 to the 4th is 16. So number 35 is 16. And number 36 probably should have left the answer choices here, which is equivalent to 125 to the negative 2/3 power. I'm going to rewrite it again. The cube root of 125, the denominator is the root, to the negative 2 power. The negative means the negative exponent doesn't make it negative, it makes it 1 over the cube root of 125 squared. The cube root of 125 is 5, and 5 squared is 25, so it's 1 over 25. Number 37, when we are adding radicals, the radical has to be the same, and so does the number underneath. So these are all square roots of 7, so I can just combine them. It's like I have 2 of them. I'm adding 9 more, that's 11. So 2 plus 9 is 11, minus 5 equals 6. And what am I adding up? I'm adding up square root 7s. And number 38 is a little more complicated, because I have a square root of 5, a square root of 4, and I have a square root of 45. So first I'm going to simplify square root of 45. I know that's 9 times 5, which is 8 times 3 radical 5, so 24 radical 5. And so I have 8 radical 5 minus 2 radical 4 plus 24 radical 5. This was the 8 square root of 20, or 45, simplified. And 8 plus 24 is 32 radical 5 minus 2. Well, radical 4 is just 2, so 2 times 2. And so I'm going to put that in front, negative 4 plus 32 radical 5. So don't get fooled by having radicals in there if they can actually be done. That's 38. Let g of x equal negative 2x squared. Find g of negative 1. What that means is I'm going to plug negative 1 into g, and then I'm going to take that number and plug that into g again. So I get negative 2 times negative 1 squared, which is negative 2 times 1, negative 2. Now I'm going to plug negative 2 back into that function, negative 2 times negative 2 squared, negative 2 times 4. Remember that I have to do my exponent before I can multiply, so that gives me negative 8 as my final answer. Number 40, let f of x equal x squared plus 2 and g of x equal 2x squared. So that's g of f of x. That means I'm going to take f, x squared plus 2, and I'm going to put it into the function for g. So I'm going to replace in g the x squared. G is 2. This is x squared, and what's going to go in for x is the x squared plus 2. And to square x squared plus 2, I need to multiply that out. That means x plus x squared plus 2 times x squared plus 2. You can't just square the first one and square the second one. This is multiplying two binomials, so you need to FOIL or use the vertical multiplication. We get x to the 4th plus 2x squared plus 2x squared is 4x squared plus 4. All that gets times by 2. 2x to the 4th plus 4x squared, oops, sorry, plus 8x squared plus 8. And that's number 40. 41, which is an equation for the inverse of the relation y equals 4x minus 4. So let's find the inverse because we don't have the multiple choice selections. So 41, y equals 4x minus 4. Now find the inverse, we switch x and y. X equals 4y minus 4, and then we solve for y. We can't just leave it as x equals 4y minus 4. So we're going to add 4. X plus 4 equals 4y. Divide by 4. And y equals, I can write as 1/4 x plus 1. Right, because the coefficient on the x is a 1, so that becomes 1/4, and 4 divided by 4 is 1. That would be the inverse of that function. And then lastly on this will be the last one for this video, is which gives the solutions of the cube root of x minus 7 equals 2. So when I want to solve for the cube root, I need to actually raise both sides to the third power so that I can undo the cube root. So x minus 7 equals 8, add 7, and x equals 15. And we don't have extraneous solutions with cube roots because the domain is all real numbers. If it was the square root or fourth root, you might want to check to make sure it works because there can be extraneous solutions.